Alright, today we're going to talk about how to graph on a coordinate plane. So first let's get some definitions down. Your first blank there is the coordinate plane. And it is the picture that you see down on the bottom right of this screen. It's formed by two number lines. So the two number lines that make it are the y-axis and the x-axis. So we usually are going to put x-axis first. They intersect at right angles. Notice they're perpendicular to each other, so they form kind of a perfect square in the middle. And when they do that, they divide the coordinate plane into four different regions. Those sections or regions are called quadrants. Now when we talk about different ordered pairs, we talked about this in class. The x-coordinate, I'm going to abbreviate that so it'll fit, but you can see the spelling right here in the title. The x-coordinate is the first number. The y-coordinate is always the second. And if you're going to plot a coordinate point, you're always going to start with the point called the origin. The origin is this part right here. It's the point where the x and y axis intersect each other, and it always has the coordinate point of 0, 0. Now, whatever your x-coordinate is, it tells you how far to move left or right. Your y-coordinate tells you how far to move up or down. So let's talk. Alright, so here's my coordinate point. The first number is always your x. The second number is always your right. The second number is always your y, excuse me. That 2 tells us, notice it's positive. We're going to move right 2 spaces. The 3 is also positive. So the y-axis is an up and down axis. We'll talk about that a little bit more in a second too. Since it's positive, we're going to go up 3. So remember, you're going to start at the origin. We're going to go right 2 spaces. Now I want you to count jumps, not lines. So this is 1 jump, 2 jumps. Now we're going to go up 1 jump, 2 jumps, 3 jumps. And we've found our coordinate point 2, 3. Okay, there's a couple more blanks that we need to do for our coordinate plane. So these are naming the quadrants. The quadrants are named from starting at this top right part. That's quadrant 1, and it's usually written with a Roman numeral. Oops. There you go. And then it goes counterclockwise around. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. And then, like we said in the paragraph, this box right here is pointing to that very center dot, which is called the origin. Alright, now I have a dumb way to remember which is which. So here's my dumb way. I always say x before y, so x before y. You walk before you fly. Okay, so think about, notice the x goes with walk, the y goes with fly. The x is always before y in the coordinate point. X comes first, then y comes second. Now the walk and the fly will help you know which direction to go. Notice if you are walking, a person walks on a horizontal surface. So the x-axis is your horizontal axis. When you fly, you're usually flying up, or maybe if you think about being on the edge of a cliff, you can fly down into the valley. So your y is your vertical axis. So a couple different things. The x before y says the first number is x, the second number is y. It also is going to tell you to go ahead and do your x, go over and then up first. So that'll help you as well. But remember, Your y-axis is your vertical axis, your x-axis is your horizontal. I know another teacher who taught it like this, where she would draw the tail of the y really long, and that's how she would remember that the y was the vertical axis. Okay, so if we want to find the coordinates of each point, one thing that's really important to do is to make sure you understand how your graph is numbered. This one's numbered fairly easily because every box corresponds to 1. So we're going to start at the origin, and we're going to say, okay, for my x-axis, or x-coordinate, I'm going to say this is for m. We go over in the positive direction, 1, 2, 3, 4. So my x-coordinate is 4. And then I go up 1, 2, and my y-coordinate is 2. Now let's do P. We're going to start with the origin again. We're going to go back. Because we're going back, our x-coordinate needs to be negative. So we're going to go back 1, 2, 3, 4, 5. So it's a negative 5. And notice we don't go up or down at all, so our y-coordinate would then be 0. I've also forgot, we'll go back and do that in a second. Okay, so let's do O now. So we're going to start with the origin. We're going to go back, so we know it's going to be a negative 1, 2, 3. And then we're going to go down, so that's a negative 1, 2, 3. So our coordinate point then would be a negative 3, negative 3. Now let's go back, and I'd forgotten to do the quadrants. So this M point is in quadrant 1. The P point, it's not in either quadrant, so we could say either none. It has to actually be in the spaces for it to be in a quadrant. So we would either say none, or you could say that it's on the x-axis. But we can't give it a quadrant number like 1, 2, 3, or 4. And then 0 is in my third quadrant. And there you got it. Okay. Alright, now, so let's graph each of these points. Notice these are not whole numbers, which I know a lot of students don't like it when they don't have whole numbers, but we can do this. 2.5, you just need to think of it as it's halfway between 2 and 3. So remember, it's x before y. You walk before you fly. So we're going to go over 1 from origin. Remember, start at the origin. 1, 2, and then we're going to go over just half a box more. And then we're going to go up 5. So from there, we're going to go 1, 2, 3, 4, 5. And there, right in the middle of those two lines, is going to be our point A. Okay? Now B, remember, x before y. So we're going to go over 0, and then we're going to go up 4.5. So here we start at the origin. We don't move left or right at all because my x-coordinate is 0. But we do move. Notice the 4.5 is positive, so we're going to go up 1, 2, 3, 4 whole boxes, and then another half, and our dot will be right there. So there's B. Okay, so now let's do C. Get that erased so we can work on others. Okay, C is a negative 1 1/5 and a positive 2.7. We're going to have to sort of estimate these. These aren't as easy, and my graph is not really big. So again, we're going to do our x. We're going to have to go back. We're going to go to the left since it's negative, and we're going to go 1 1/5. So imagine if I magnified one of those boxes, and this is one of the boxes. Well, imagine it being divided into 5 different sections. We need to move over just 1/5 of those. So it's going to be just about right there. And then we're going to go up 2.7. So up 1, 2, and then if you think 0.7 is a little bit more than half, so this point will end up being about right there. And then the last one, 2.3, negative 3. Let's do that one. So we're going to go out 1, 2, and then we're going to go 0.3 further. and then it's a negative 3, so that tells us to go down. So we're going to go 1, 2, 3 down, and our point will be about right there. And then we got it. Okay, so let's continue. That next sentence, it says, a graph of an equation is the set of all ordered pairs that are solutions of the equation. Remember yesterday when we plugged in coordinate points and we saw if they worked? Those points that worked are called solutions. Well, if you want to graph an equation, you just graph enough of those solutions that you can see the shape that it would make if you graphed, an infinite number of different points. Okay, we're going to graph the equation of each of these lines, and I'm going to read the directions for us. Complete each table of ordered pairs. Graph each ordered pair on a coordinate plane. Draw a line through the points to represent all possible solutions. So there's no way for us to make a table that incorporates all the possible solutions for these two. But we can get enough solutions that we can graph it. We'll get close enough. So a little bit better. And let's do them. I think it's always wise to try to plug in a negative. So let's start with a -1. Let's do a 0, a 1, and a 2. So if we plug them in, this is going to be a 2.5 times -1. So my y, it's a little bit wide, my y then, if x is -1, my y is going to be 2.5 times -1. So it'll be a -2.5. Now all we have to do for that third column is write our answer as a coordinate point. So it's going to be the point -1, -2.5. And then we can graph it. So -1, I don't even have it big enough. And then -2.5 is going to be about right here. Okay, so let's do 0. So we do 2.5 times, and we'd plug in a 0 for x. So our y would be 0. And if we wrote that as an ordered pair, we'd get the point 0, 0. Okay, so next is 2.5 times 1. That's 2.5. And so my coordinate point would be 1, 2.5. And I could graph it. Here's over 1, up 2.5 would be about right here. And this is really enough information. We can connect those points with a line, but let's do one more just for the sake of practice. So 2.5 times 2, that gives us a 5, and our coordinate point is the point 2, 5. Now go over 2, up 5, and then we can connect our points with a line, and we have just graphed our equation. Okay, so a good time for you to pause and work on this on your own, and then you can come back and check it. Okay, so hopefully you guys have gotten this now. Again, let's do some negatives here. Let's do a -2, -1, 0, 1, and 2. How about? I may not get finished with with all of them, but we'll do it quickly. Okay, so we're going to plug in the x into the equation that's shown. So it'll be a 3 times -2 minus 2. So 3 times -2 is -6. -6 minus 2 is -8. So my coordinate point is the point -2, -8. And I can go here, and I'm also not going to have room, but it's down here somewhere. Okay, -1, we're going to put a 3 times a -1 minus 2. So that would be a -3 minus 2, which is a -5. And then it's going to be a -1, -5. So -1, and then down 1, 2, 3, 4, and 5. So there's my dot. For 0, it's 3 times 0 minus 2, which would be a -2. And 0, -2 gives me my next point. And I have enough points to be able to make my line. I'm going to stop there. I'm almost out of time. Hopefully that was understandable. If you have any questions, please email me, and I'll try to get back to you. You guys have a good day.
Made with Doodlecast Pro.